a bunch of bananas are attached to the bottom of this spring. We know the constant of the spring is 16 Newton per meter, and we also know the amplitude, which is the x max, and we also know the velocity maximum. Now, if we look at our equations for velocity, for Vmax, we should see that like Vt is going to be equal to Vmax times sine of Wt plus this phase constant thing. We're really interested in this part because we can also replace Vmax with negative xm times w. Let's ignore the negative sign, but let's consider that Vmax is equal to xm times w. And since we know xm, we can basically say 37.4 is going to be equal to 20 centimeters times some w. And so now we basically have the situation. W is going to be equal to this stuff right here. Okay, so now we know W. What does that really matter for us? Well, if we see K, K is going to actually equal mass times W squared. And because of that, we could basically just square this thing right here. So we could say that 16 Newton meters is going to be equal to the mass that we're interested in times W squared, which is 37.4 over 20, and then we'll square that. So let's try 16 divided by 37.4 over 20, square that. And so we get that the mass is equal to 4.575 or something. Well, that's nice, but what about the acceleration? Just remember that the acceleration is actually gravity, so A is equal to 9.81, and so that's what we could plug in over here. So times 9.81, and we'll be able to get the newtons of this situation. 9.81. That'd be 44.89 newtons or so. That's pretty cool.